Good evening to all the participants. So today we are going to start our session 3 and session 4 from the continuation from the previous day. So welcome to the online faculty development program on deep learning and intelligent video analytics and computer vision. So without wasting much time, I am going to hand over our next session to our the team of experts in the computer vision. So I request the resource person to uh, continue the session. Thank you.
All right, noted. Okay, let me share my slides first. Okay, uh, can you see my share screen?
Yes, sir.
Okay. Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh, and very good evening to everyone. I hope this workshop finds you in the best health and spirit. My name is Hamid, and I'm today presenting on behalf of Dr. Ahmed Rimaz, and I'm very honored to welcome you all to this workshop on OpenCV, which is a very exciting and a powerful tool for computer vision. So first and foremost, I would like to make a moment to express my gratitude to the organization of ATAL, ICT Training and Learning Academy in India for arranging this wonderful platform where learners, and I also would like to bring warm greetings from the Center of Unmanned Technology, CUTE, in IIUM, the International Islamic University of Malaysia, where I'm proud to be a part of. So, uh, before we start, I would like to assume that we have like people from various backgrounds. So maybe some of us have knowledge about like computer vision programming, and like the rest or some others, maybe it's a new topic for them. So what is OpenCV? OpenCV is it's a shortcut for open source library for computer vision, for machine learning and image processing. So uh, in computer vision, we deal with pictures, videos, and so on. So we will have to find our way to manipulate and work along these materials. So that's why we need to have a strong foundation about OpenCV, which is a library designed for real-time computer vision and image processing, where it provides tools to process images, analyze videos, and detect objects and features. There are a lot of like OpenCV tools that can help us achieve our goals. Some of the tools can deal with images, such as when we have an image, we can like do some basic operation like resizing, rotating, cropping, flipping, and so on. Another tool is dealing with each pixel alone. So when we talk about uh, pictures like we take it as a 2D shape that have number of pixels height and another number of pixels which is on the width. So we can like for example, if we are interested on a certain number of pixels or like 1 pixel, we can do some filtering to that. Also, we can use OpenCV for object tracking if we are interested in an object in a picture. uh, we can like do some noise cancelling and background subtraction, and also like one of the main important thing about OpenCV is that it can be integrated with some pre-trained deep learning models, and it supports like very popular frameworks such as TensorFlow, PyTorch, which inshallah the 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 workshop will be explaining on the sessions later on. So as we can see here from this picture, we have like some fruits, and we can change the colors, manipulate, do some filtering, and to get like the result that we need. Also, it can deal with the videos, where if we have an object, we can do a lot of cool stuff with it. Where is OpenCV used? Right. So OpenCV is used in like various daily day-to-day applications such as healthcare, where it can be used in like analyzing medical like images such as X-ray and so on. It's also used in automotive ADAS, where in like cars we can have like sensors, cameras, and so on. It is used in robotics because for any robotic to be autonomous, we need like sensors, and they can also like utilize computer vision. So OpenCV, alongside deep learning and AI, is used in many of the day-to-day activities. So that's why I make it very important. Next thing I want to mention is what we need to learn or what we need to have to start with OpenCV. So firstly, we will have to have Python. Uh, Actually, OpenCV like one of the good tools because it also can be used in other programming languages such as C++ and Java. But in this workshop, we are interested in Python. We will need to have some other libraries such as NumPy, where it deals with a library that deals with arrays and numbers. We need to have Pandas, PA, that can be helpful for data analysis. And one of the important one, we need Matplotlib that can help us plot the pictures after we do the necessary operation on them. And we will need, of course, OpenCV. 3.1 is the latest version. So here we have some tools that we can use for OpenCV. Firstly, we have the Python, the programming language, and we have Anaconda. What is Anaconda? Anaconda is basically a virtual platform that can give us access to Jupyter, where we can have our notebooks and try our code basically. So how to install if we want to use this way. So these are the simple line of code to install firstly the Python, the OpenCV, and the libraries. However, as said before, like we have various people from various background. Some of might not be aware of Python and how to install it, how to deal with libraries, because this is the first step is to install like all Python and all the libraries. And if this step is messed up, like a lot can go wrong. So that's why I would like to use Google Colab in this workshop. So what is Google Colab? Uh, it's a it's a free browser-based tool that is created by Google. So it's basically allow us to write and run Python code. So we don't have to install Python in our own laptops, and it's a it could host like it's basically another version of Jupyter Notebook. There are like some amazing features of Google Colab, such as like code execution. So basically, like it can run any code that we use, and you can storage your notebooks in Google Drive. So that's a lot of like storage, and a trick that a lot of us do is like creating a new account to have like more storage, to more free storage. Also, we can share like sharing the notebooks as we share like the Google Drive links. It has most of the pre-installed libraries. So some of the libraries that we will need, such as NumPy, Pandas, Matplotlib, they are already installed. So we can right away start working on them. And it has a graphic process unit, meaning that uh, of course, this is for the free version. It will give you, I think, roughly 3 hours for free graphic processing unit, where you can connect to. In Google, they have like those huge very powerful like computers that you can connect and do your like training. If you have a very intense, very comprehensive like AI model, you can use that to train. But for the free version, it only give you like a limited time. So there is of course a paid version from Google Lab. uh, Before we start our workshop, a very important point, and one of the huge application of OpenCV, that it is integratable and we can use it with deep learning frameworks such as TensorFlow and PyTorch. We use TensorFlow and PyTorch to create those AI models that help us to make our CNN. For example, let's say you want to make an AI model that can, for example, you give it a picture and it will tell you there is a pothole or no. So for example, for that, we use a TensorFlow, or you can use PyTorch. So in that, we will have to deal with a lot of pictures. We'll have to give like set data with like for example, roads with no potholes, and another set data with road with potholes. So how to deal with all these images. And it also like support like pre-trained models such as YOLO, which we will be learning in the future sessions, which can help us do object detection, image classification, and semantic segmentation. So without further ado, let's start our workshop, and let's go to the notebook. So I made this Google notebook. I will share the link in the chat. if some of the guys want to follow along and code along. But I would advise just like listening and understanding what the code does, and then after that you can try it yourself. I want to ask you. Okay. So this drive link here, I have my Google Colab notebook, and here we have like some images and videos we will be working with along the session. So we come here on the Google notebook and we just open it. Simple as that. So this is like one of the. So it will take a long time to load, but I already have it loaded here. Reconnect, yeah, because I haven't touched it. Okay, so before we start talking about OpenCV, I would like to more emphasis on some of the like pros of using Google Colab and how to utilize AI. So basically, let's say I'm writing a code and I'm writing a Python code where I want to print my name, but I use the wrong syntax. Of course, the code will tell me like there is an error, but the good thing about Google Colab that it is integrated, like Google integrated it with AI. So like in some code, it can help me fix the code and give me like a solution. So for example, here it will suggest, oh, since we're using Python, we need to have those parameters, and we just clicking that. So now it's so this is, and also like we have Gemini, which is an AI tool. You can like always ask to help in your code. Okay, so since we are using Google Drive, pictures for the Jupyter Notebook, you can just upload the pictures in, for example, a file on your laptop, and you need to know the path of that file so you can link it. But here we are using Google Colab. We will be relying on our Google Drive. So for example, I have these pictures here, but how can I link them to my notebook? So after, make sure like you are opening the Google Drive and the Google Notebook in the same email. And after that, we can just mount the Drive to our collab. So mounting it, it will ask you to give access so that Google Colab will access your drive, and it will access any information that is there. I already mounted my drive. So here, after mounting the drive, I will see this drive icon here, where I can see my drive, where I can see all the all the folders I have here. So if we go my drive, I only have one folder, open CV workshop, and if we go to that, I will have the notebook and some images that we will be working along. And a second thing I want to spotlight on in how to copy the path. So as said before, if we are using Anaconda or Jupyter Notebook, so we'll have to know that path. For example, C and then the name of the folder and then the name of the file. Here, you just need to right click on the image and you just copy path, and that would look something like this. So it will look like config drive my drive, which is, and then it will give you the path. So it is easier. You just copy and paste the path, so you don't have any mistakes in that. Okay. Uh, First, before typing any code, we need to know what libraries are we using. So I said before, what are the libraries that we will need for the OpenCV so we can manipulate pictures. We'll need NumPy, Pandas, Matplotlib, and OpenCV. Those three, it's situational. You will not always need them, but if you are working on a more complex project, of course, indeed, you will be needing those. Okay. So after importing them, as said, they are already pre-installed in the Google Colab. So all I have to do is just import them and write the code. Also, an extra thing that Google Colab has is the patches. So they have their own version of some functions. So we are using that because we are using OpenCV. So OpenCV, how to deal with pictures. The first step is how to read an image. So you have an image, you want to read it and visualize it, and then make some operation on it. After importing the CV, which we already did in the first step, we will just name it. For example, I named the image img, start for image, and then we will use this function cv2.imread, and then we will just copy the path. So for example, this is the image that I want to copy the path of. It's an image of a cat and a dog. So we just copy the path, and we can paste it here. So now there is a variable called img that is storing the pictures of the cat and dog. Second step is how to visualize, how to show that image. So this is the function cf2 underscore I'm sure, and we use the same variable that we used before. So if we run this code, it will tell me there is a mistake. So some of those code, because they are handwritten, they have some mistakes. So that's why we can use the Google Colab feature, which is how to deal with those errors. So if I use AI, it can easily help me to yes, doctor, can easily explain me what is the error. So the error is in the attribute, and it also yes, yes, doctor. Doctor, do you have something to say? Okay, so we'll just continue. So it will tell me here after that it will tell me error. The code now checks. Okay, so we can just use. Okay, so we can just try the new code that it's given, and we can try it to see if it's. So it could not load the image from the Google Drive GPG. So maybe there is an error of the pathing. Copy path. Yes. So now it will should upload the new path, and if we go to the all this code, now it should work. So basically the error was in the path before. After I changed everything, I added everything to the OpenCV workshop, the path of the images change. So now after using the IAMShow function, now we can see the image. But there is also another way to plot the image, which is using the matplotlib, which we talked about earlier. So we just imported as PLT. And what did this library help us do is it give us more room to work on with pictures. So for example, if I plot the picture using this library, firstly we can see how many pixels we have. We can also add a title for the picture we have. So for example, it's an image display with the function, and we can remove the axis if we not. So basically this library give us more room to work on and deal with the images. Okay, so now if we have an image, what sort of information we can know about that image? There are a lot of information, and some of them like are important later on, because for example, if we want to for example merge or add two pictures into one, they must be in the same size. So that's why we need to check the size and make sure they are in the same size. If not, we will have to resize one of the image to be the same size as the other, and we move on. Okay, so firstly we can know the image size. What is the image size? So every image we have is a 2D dimension, where we have it in pixels. We have the height and the width. So basically after going to the code, so we are printing the shape, and it will give us firstly it will give us in this is the image shape. Yeah, the image shape, it will give us a third column in the z direction, which we are not interested in. So we just and the size is the number of pixels we have in the x, y, and x and y direction. Okay, so these are some information that we have on the pictures. Thirdly, we can know the data type of the picture we have. What is a data type? Data type is how many bits are the picture, and most of the pictures we use are in the 8-bit data file. So it should give us the unit 8, which is 8-bit data type. And okay, so there's a lot of other information which are not maybe necessary, depending on the application of or the usages of your for example your AI model that you want to create. You can also know the color distribution for the RBG. It will tell you like in this for example pixel there is more red and that pixel and so on. So if you are interested in this information, it can also give you the mean and standard deviation of the pictures, and the aspect ratio, which is the width divided by the height, if it's needed. And another thing is the intensity statistics, which uh, which we'll talk later on. Uh, another final thing that we can know from any picture is the RGB values. So the green, blue, and red values in an image or in a single pixel. So here, for example, we have the image and we are interested in, for example, a single pixel, which is in this case 100 by 100. So if we go to the image, we will have this pixel 100 and this. So we are interested, for example, in this pixel, what are the RGB values in that pixel? So we will just decide what pixel values are we interested in, and it will give us the RGB color code. Okay, so this is just like overall. It's not really that important to know all these details, but it is kind of to know about them and remember them if you need them in your application. So now let's go to the fun stuff, which is how to operate on pictures and what can we do with it. So firstly, we need to know how to resize a picture. So resizing a picture is changing the number of pixels in the height and width, and it can be done by, for example, this picture. Uh, as you can see here, it is 175 by 250 or by 275. So if we want to resize these pictures, so for our data set to be all the same size, we can easily just use the cp2 resize function, and then we can determine what are the number of pixels we need the new resize image to be. Okay, is that clear? So basically, again, if we need to resize an image, we will use the cp2 resize function and decide the number of pixels we want to be. So after resizing it, it will look a little bit different than the one before, because the height is now more. Okay. Another thing is rotating the image. So rotating the image is we are interested in couple of parameters. So this image here, it has a height and a width. So to rotate an image, we are interested on the center point. Okay. So firstly, we will get these values. What are these values? This is the height and width of the image. So we will get these values using the img.shape. And what is this here in the parameters? This is meaning that we will take two numbers only. So it will make it simple. After that, we will take the center. So center is the height by 2 and the width by 2. So after writing the equation, we will have this center point. Now, to rotate a matrix, we will use the rotational matrix function, where it takes three parameters. Firstly, it will take the center value, and then it will take the angle that we want to rotate it, and then thirdly, it will take the value of ratio if we want to scale down or scale up the picture. Okay, after that, we will have a new rotated image after applying whatever matrix values we chose, and we can show it. So for example, let me not rotate the picture. Let me make the picture as it is. So putting the angle 0, meaning that the picture will stay stationary. Okay, let's try. So the picture will be still the same. Now let's try rotating it 45 degree and maybe scaling it up a bit. So we can scale it to 1.5. The center value we cannot change because it depending on the picture. So it will calculate the height and the width, divide them by 2, and give us the center value. So after rotating it, it will become something like this. So it rotated 45 degree, and then it scaled up. So now it's more zoomed in. Let's bring the scale back to normal to see the rotation. So this is the picture. Of course, the black is there is no values of pixel there, so it will just give black. So let's now make it, for example, vertical. So to make the picture vertical, we will just put a 90-degree. So, and then let's say if we want to rotate it horizontally to be on the other side, we can just adjust the degree to our liking. Another thing is drawing on a picture. Why drawing on an image is important? Because let's say we have a data set of images that contain potholes. So before we can train this data using YOLO, for example, we will have to take the pictures and kind of like draw where the pothole on using a rectangular, so that the AI model will understand and like learn that this square contain the pothole, and so it can pick up the pattern and so on. So to draw a rectangular on a picture, it takes four parameters. So this first parameter is the top left corner. So for example, this is pixel 50, this is pixel 50. The top left rectangular will start here. And this is here, the bottom right rectangular point. So basically here is a point and here is another point that will let us draw a rectangle. Finally, here are some values for the rectangle, like for example, the color we use, the thickness, number 3, and so on. Let's try this code alone. So we see how it is when we write. Oh. So this is drawing a rectangle. Of course, I did not put any code restoration on the colors. We will get that. We will get to that later on. So here is the rectangular. So we start from pixel 5050, end up on a pixel, and let's change the pixel number to see the difference. For example, I put 25, 25, and 70. It doesn't have to be the same number, by the way. Okay. So this is another rectangle. Okay, now let's get on typing, for example, letters or writing anything on a picture. We can use the function put text that will allow us to write whatever we want on the image we choose. So, and we can also decide where we want to write the letters using the coordinations. So for example, we can use this rectangular that we drew as a reference, and from there we can draw our letters. So let's see. So here are the two rectangulars we did earlier, and here is OPENCV, which the code right here, and you can basically write whatever you want. So this is for drawing on an image, whether it is a rectangular or any shape. You can write any other shapes. You'll just need to know the code and follow the syntax for them, and writing on a picture. Okay, let's go to the image cropping. So image cropping basically is taking a specific part of the picture. For example, I'm only interested in the right half of the picture, the dog part. So basically, I can decide what the pixels I want the cropping from. So here is for the x-axis. So I want to crop from 50 to 200. And here is for the y-axis. So basically, you specify for the row and columns. And finally, like you visualize the new picture after being cropped. So this is after it being dropped. I can change, for example, where I want the crop to be. For example, let's say from 0 to 100, and from 0 to 100 as well. Okay. So it will crop the top left part. That's for image cropping. The other thing, one of the most important operation that we can do on the images is converting them to grayscale. And this is an important step because later on, when we deal with some AI models and object detection, you will see this line a lot in the code, because we need to always, sometimes, not always, but most of the times, convert the pictures to the gray using the grayscale, so we can deal with them. So basically, we'll just name a new variable called the gray, or a gray picture, and we will use the function CBT color. So what this allows us is After using the function, here it will take one parameter is there are like different syntaxes for like different colors or colorways. For example, making it lighter, brightest, contrast, and so on. But this is for the BGR to gray. So for example, here we are switching from the blue, green, red to gray, and this is the syntax that we have to follow. So after switching, you can see that it will be gray and black. Okay. Also, not only that, not only we can also like play with other colors and change the brightness and so on. So for the brightness, there is a brighter version of a picture and a darker version of a picture. So for the brighter version, they both use the same function, which is convert scale absolute. So the only difference is the values of the beta, which is related to the brightening color. So if we use 50, it will make the picture brighter. If we use minus 50, it will make the picture even darker. And then after that, we just visualize and show the pictures. So for example, let me run this code and see. Okay, so here is the brighter version and here is the darker version. Of course, like some of you will ask, what are the usages of these functions and making the picture gray, darker, brighter, and so on? It depends on your project. And while are you dealing with pictures, you will notice that, oh, I want all my pictures to be in the same colorway. For example, some pictures aren't, so I will have to maybe switch them to match the others, and so on. So it's basically depend on what project are you working on and what do you want to achieve at the end. So once again, we'll create new variables, brighter image, darker image, and we'll use the same function, which is convert scale absolute. So it takes three values: the image, which had the image pathway, the alpha value, the beta value. We are interested in the beta value that will control the brightness and darkness of the image. We change the value. We can even change it to different, like for example, image at 25. So it will even less brighting. It will be more normal, and so on. Another operation that is important is padding and masking. So padding is adding borders to the picture, and we can use that by this function, which called copy make border, which basically just add a frame to the picture, and you can decide the thickness of the border that you want to be, and use this syntax for the border. So after writing, it will look something like this, where we have the picture and it has a red frame. So of course, this red is also like from the values here. These values are for the green, blue, red. So if you want it to be other color, you just do here. For example, earlier for the rectangular, we used the blue colorway. Here we use the blue colorway, so that's why it had 255 in the first axis. Can't find it for some reason. Wait, resizing image, rotating image, drawing on image. Yeah. So here we have 255 in the green. So it's a green. In the blue, green, and red. It's just preferences basically, or if you require some exact colorway. And masking. For masking, we'll have to use one of the libraries we mentioned before, which is the NumPy, that will deal with arrays and numbers, and the data type of the pictures, as we know before. So for example, here we need to identify the data type, I mean. So if we are not sure about the data type, we can just, as we said before, one of the information that we can get from the image is the data type. So from like using this code, we can know what is the image, the data type, to tell us the data type. If we and so on, we can use it in future codes. So masking. Basically, masking is you care only about a specific part of the picture. So what you do is you create a new black picture or whatever color that will mask on the original pictures, and it will show, and we will have a circle. This circle, it will be empty, and this circle will be in the place that we are concerned on. So for example, we are only concerned on the the dog and the cat pictures for object detection. So we will make a circle here that make them visible in the picture, and for example mask everything else that we are not interested in. Okay. Histogram equalization we will mention later in the filtering and in the enhancement of pictures. So the last operation that we can do with pictures is blending two images together. So if you have two images and you want to combine them together, for example, I have an image of Messi and another image, the debate in football. Add them into one picture. Screen. Oh yeah, okay. So here, so firstly, as said before, we will make a variable for name image. So for example, I call them image 1 and image 2, and we write the path. So to double check my path, I come to the picture, right click and copy path, and I will just paste it here because I said I changed the path earlier, so it should be different now. Yes, and we do the same thing for the other picture. So that's like one of the advantage of Google Collab. It make it easier, but for like just small project. And then I press here. So this is the path for both pictures. As we said, if we want to blend two pictures together, they have to be the same size. So before we resize one another, let's check the size of each picture alone, and then we see. Okay. So firstly, we make the path, and we can go before to where we learned how to check the image size. So to check the image size, we just use the image.shape basically. Okay, so you can just copy the code. Also, as said before, I linked the Google Chrome, the Google Colab. So if you would like to code along, feel free and ask me if you need anything. So we just check the shape of each image, but of course we need to make sure this is image 1 because it's different, and we check the size of it, or the shape. So we can see here it's 1725 by 2352, and we can do the same for the second picture. And we can see it's different, it's much smaller. So blending here will not work. So before that, for example, let me remove this code. This line code basically resize one of the image to be the same as the other image, but let's say we do not include it. Like look at the error. It will tell you that two images to be blended, they have to be the same size. And we can use the Gemini that I mentioned earlier to explain like the problem exactly. So it will tell you the first image has a shape of 1725 by 2352, as I showed you using the code, and it will tell me the second image has a shape of 183 by 275. So we have to resize one image to be the same as another. Previously, the image resizing we did is by choosing the number of pixels in the height and in the width. But here it will be inconvenient to do because we will have to memorize the pixels of the first picture to apply them to the second picture. And in Python, we like to do shortcuts. So here usually we write the number of pixels in length and number of pixels in width. So what we do is we will imagine any picture as an array that has values. For example, let's say 1752, I remember, and 2532. So this is the number of pixels in height and width. This can be referred to as image 10. So this means the value in the first here, which is 172. And let's say image 1 is the value of the second, which is the width. So using this information, we can only like write the code this way, and the other way works, but this is like more convenience, and it improve our understanding of coding and Python. After that, we'll use the add weight function, which is image 1, image 2, and we can have a ratio, like which image we want to be more focused on. So if we make the ratio same, which is 0 0.5, 0 0.5, and we can see how let's firstly see one image to be like high contact than the other to see what do I mean by the focus. And after that, we use this code we should be familiar with, which is CV2 underscore I am sure, to show and visualize any picture that we are interested in. So here we see this is the image 1 and this is the image 2. You can see that image 2 is not as focused. So if we switch the values, so you will see that the second picture of Cristiano Ronaldo has more focus on the first pictures. Okay, so before we move on, I'd like to ask if anyone has questions, because this is a very important part, is how to do operations on pictures, how to work your way along them, and basically reach what you want as a result. So, you have any question, or should we move on to the next part? Okay. Okay. So here, that's about pictures. Now let's talk about videos. OpenCV as well can work with videos, and it can read a video and display it, and this will help us with the real time. For example, if we are using a camera, for example a security camera, and we always want to keep an eye on people who are entering or leaving the mall, so we'll have a face detection and it can be linked to the security and so on. So let's see. So for example, let's see, we have a video here, vid one, which we can see. So I have to, for example, open it from here. This is video one. So basically, it's a video of a cat, right? And let's see how can we, first of all, we make a variable for it, for cap, shortcut for capture, for example. And we use this function, video capture. First thing first, as I said before, we make sure that the path is correct. So I can double check by copying the path here and just pasting it here. So, and then this line, which will only read the video. So if I execute this code, it will not do anything, because the only thing that we add the code to do is to read the video and store it inside the cap variable. So if we want to play the video back in Google Colab, it's a bit long, because we don't have all the function that we have in Anaconda. So we'll have to use a little bit of HTML. I will not go through the details of this, but we can talk about it in another session maybe. So firstly, the video writer, we make sure that it is in the MP4. So if the video we originally have in other formatting, it will change it. Secondly, we will video write and have some parameters. So what this code will do is, while the capture is open, meaning that the video did not finish, we uh, will just play the video. And if the capturing finish, the video will stop. That's basically how it is. Okay. So yeah, this is no file. Okay. So I go to the drive to double check that the video is there. I sent the drive earlier, so I hope you guys can see it. Okay. Maybe there are some questions. Sir, we are unable to mount the content drive. How to do it? Okay. For the first time, if you mount just to go back to the mounting drive, it will ask you to log in into your Gmail and just accept the terms. I will try to open a new tab with another account to show you how to mount it. Let me open a new Google account tab. Wait. Okay. So let me open my other email. I hope I did not. Okay. So let me, 1 second, Google Lab. So I'll create a new notebook. Oh, okay. Hold on. Google Lab. Okay, notebook. Okay, I have to, and I will. I need to. I need to share my screen with the all the tabs so you can see the second tab. I will end my screen for a second, then open the whole screen. Okay, I need to share my screen. Share my entire screen. Okay, the entire screen. Uh, this screen. Okay. Can you see my screen again? Okay. So can you see this new tab? Can you guys see the new tab? Let me double check. Okay, you should be able to see it. So after running the code in a new drive, it will ask me to permit this notebook to ask it the Google Drive. So basically, I just connect and choose my email. This email has not been linked to Google Colab yet, and I will just approve to the terms. You don't have to approve to all of them. You can read through. I always just select all and continue. And then it will tell me that my drive has been mounted similarly as the other. What I can say it, at the other notebook says. Okay, so here it says already mounted because, but if it's first time, it should say that it is mounted at content drive. And when you open your files drive, you can see my drive and all the files you have here. So this drive has a lot of files. Okay, should answer your question. Let me check in the app. Okay, can you do it now? Is it working now? Can can someone double check? Okay, I see some thumbs ups. Okay, another question. Can I resize the image by 50% aspect ratio? Yeah, you can always can. I would advise I will share the notebook after, and you play around with the code to see what you can and cannot do. Download Google Drive material and upload in Google Drive and the appropriate path in Collab notebook. Mm, Mounting problem is resolved. Thank you. Okay. Okay, so let's go back to the drive again and we can open the notebook. Okay, so are you guys clear with the hidden input here? Are you clear with the operations on images? Because this is a very important part of the OpenCV and it is the very beginning. So here, image operation, we have the resizing, rotating. So basically rotating can be the same as there are other functions such as flipping. So we can do flipping and we can do rotating. It's the same thing. The only difference is that when we rotate, we will always have, for example, if we rotate 45 degrees, as we said before, we will have these black pixels. But because flipping is only you flip in the X direction or the Y direction, it will not have. So it's basically the same as if you flip it with a 90 degree like this. Okay. This is the image after the original image would not have had these black pixels. And then we talked about drawing an image, drawing a rectangle, typing test. And then we have image cropping. We have convergence to the image gray, change the brightness darker, padding and masking. Okay, and images, talked about this. Okay, working with videos. Let's go back to working with videos. I need to go back to the other. I will end my. I have it here. Okay, so yeah, it's very new to me to deal with these screens because the code for the video is on my other notebook, so I need to get that out. Okay. Okay, so let's go back to the working with videos. After we I have an issue. My Google Meet is now working good. Yeah, should be fine now, right? I hope so. Okay, let's go back to playing the video as we said. So let me double check. This is the link of the video drive, my drive. So this is the vid1 link. It should be fine. Then it's giving us the same error, which is no such file. I think on the drive. Yeah, but I changed it. Oh yeah, because I have it here as well. Yeah. Okay. Copy the path, the new path, and I will add it here as well. So coding is a lot of trial and error, especially if you have this long coding. So here, after using the OpenCV integrated with the HTML, for if you are using PyTorch, or I mean, like if you are using Anaconda and you have like Python and OpenCV on your laptop, you will not have to go through this struggle, but it's a Google Colab thingy. So after that, we'll just basically be able to see the video as it is. Video cat. Okay, so that's how we work with videos. We can, okay, so in videos there is another way to work with the videos, is by having them frame by frame by frame. But for example, a video of 2 seconds will give us like a lot of frames, more than hundreds, could be thousands. So for example, if we are interested in only one frame, and that frame we would like, for example, to do some operation on it, for example, like for example changing the colorway and whatever. So for example, here we can choose a certain image. So by, as I said before, I need to change the, the path. So here we will choose a certain frame randomly. After that, this frame, we can do some operation on it. For example, we will change the color to gray, as we learned, and we can have some edge enhancement, and we will see the difference between the colors if we play the guide. So for example, it showed this frame of the picture, and then it did the operation we talked about, changing to grayscale and edging the frames. Okay, that's all. Before we go to the next interesting top, is how to deal with object detection, and for example, object detection in both photos and videos. So please, if you have like any question, I would like to answer them now to be better, because object detection is more in depth. So you feel free to ask anything. Give like a couple of seconds, maybe like 1 minute too, so everyone can take all this information. Let me know if you need something. Okay, should be fine. So we move on to the object detection. So object detection can be done in pictures and videos. It's way easier with pictures, but it's also like doable with videos. But videos will either have to choose to deal with them in real time as the video is moving, or to stop them frame by frame and work each frame alone. So for the object detection in images, so for example, we have this picture. of a smiling man, and we will use a pre-trained model to do some face detection. Is that clear? So as we said before, firstly, the process is simple. We should know it by now. Is we make sure we know the image path. So this is test one. I will just double confirm my image path and just paste it here. So this is the image path, and then we'll read the image, meaning that we store it into variable. So these two can be done in one step with one line. After that, we will have it as test image. So let's see we want to see the image before we do the face detection. So it will have contact runner. There's supposed to be a space here. Should be fine. Okay. Yeah. So another thing is, let's say we want to see the shape of the image. If we are interested in it, we'll just can print it as well. Secondly, in this case we are using a pre-trained model which is called Cascade Classifier. It's a pre-trained AI model in Python that you can use to do simple face detection. So before we load the classifier, this classifier requires the image to be in gray. So we'll do the gray scaling as we explained before. So here we will have the gray image, and we will do the gray image is a new variable that we are going to take out from the test image, the previous variable we had, and basically do this function which is color bgr blue green red to gray as done before. And we should have a new image called gray image, which is the same image but in gray, and we can show it and print, for example, the shape. You see if the shape will different if we do the grayscale. So this is the same picture but in grayscale, and notice that when we do it in the grayscale it only becomes like a height and width. We don't care about the number 3 here. It means that red blue green we're not interested in. After that we load the classifier or the pre-trained modular. It's I can call it, I can name the variable as I want, like face classifier, face detection. It's up to you, but we are using the cascade classifier function, and here it's be already saved at this name. So basically you just call it. It's just calling and loading the classifier. After that we will have a new variable called the face. So meaning that we are concerned what part of this man is his face, and we can do that using the classifier. So we'll use the function multiscale to scale up the pixel, and we are inserting a gray image as an input, the scale factor, and other parameters. So let's load the classifier and perform the face detection. After that, after knowing the face, we would like to point it out which part of this man is the face. So basically we can draw a rectangular as we learned before, or you can call it a bounding box on the face. So we already has a variable called face that has the pixels which are x and y. We don't know the x and y value. I mean we can show them, but we just interested in drawing a rectangular. So cp2 dot rectangle, we have the test image, and we have the x y values. So we will draw the rectangular by adding a width and a height. Finally, we can use an img rgb. It's just a variable RGB because now the picture we have is in gray, but we want it back in colors as it was before. So we will just convert back to the RGB from the gray. Finally, we can use Matplotlib to see the final results. So it will load and it will have the new picture with image. It can work on any different image. You can test out. You can even improve the code by, for example, inputting some famous names and their pictures, training the modular so it can give you the face detection and the name as well, and so on. So this clear how to do simple object detection using OpenCV with yeah. I shared the link. Okay, wait. Let me see. Someone raised their hand. You can actually. Can video clip. How can it where the file saved? It is saved in the cascade. It is saved in the cascade function. Like when we call out the cascade fire, it's already saved. So you just call it out by the name. It's not like it's saved on your computer, but it is a part of the function that of the classifier that we already load. Is that clear? Uh, I will go back to the video because it's require HTML. Can we use it for leaf detection? This classifier is only for face detection, but there are like tons of different classifiers that you can find in the internet for different reasons. For example, like detecting whether this a cat or a dog, and so on. So you will need to find the classifier which already be pre-trained, and you can use it on your own data. So basically, just test it. This will be covered more in depth during the next sessions. We will be talk about PyTorch, Shiolo, and like very intensive AI models. So this is the very basic one. Uh, is it in your current directory? We need develop a live detector. Okay, we can do that after if we have extra time. Okay, let's go back to the video clip concept. So here we have a while. So how does the while work? While is a loop function that will start and finish when the condition is not obtained. So while the capture is opened, what the capture is the video that we named earlier, and while is open, this function will check whether the video finished or not. So while the video did not finish, it will run this code, and then it will run this code, and then if it finished, we will just break and exit the code. And this code is the similar we use after here. It's this basically is just to frame out the video. So this code will just give us one frame, but then how after we can turn out those frames into one video, because now we have the video as like, let's say, hundreds or thousands of frames. Then we will use HTML, because I said before, Google Colab doesn't have the function that can allow us easily to play the video, unlike if you have Anaconda and Jupyter. Especially if we plan, for example, if we want to use our webcam, we can easily open our webcam with Python, but for Google Colab, you will have to use Java as well. So basically, after giving this information, which is the video path, and what is the video file? Video file is basically the path and the RB, and finally the B64 encode function. We will use this HTML to open a window. This HTML will allow us to open this window, and we can put the length and width of the window, this window, and basically we will tell it just to make all this frame using the B64 encode into, like, connecting them together and putting it back into the video as it was before. So this is briefly like how did the code work. And here, if we go to the other code, without using the HTML and encoder, we only have one frame, as we said before. So let me see. Okay. I'm sorry to post questions instead of yes, there are a lot of classifiers you'll use. At the end, inshallah, I will give you some references, websites, and some websites and like a YouTube channel to see like different classifiers and how to use them. However, before even talking about that, in the next sessions, we'll also, by different lecturers, we also get to know the YOLO V5, which is, or YOLO V8, whatever they are planning to use, which is a very huge AI model that is already pre-trained, and it have tons of different classifiers. So um, that will, if you wait for the other session that will answer your question more in detail. For the moving aperture, which classifier can we use? I will I will give you, I will show you like one reference I have that how to say it, that has the step by step on how to do a video, for example, and maybe you can try it as a task. I didn't have the time to show it here, but let me open the reference and show it to you guys, and then maybe you can try it by yourself later on. And I will leave my, for example, WhatsApp number. You can message me if you need anything. So let me find the link for that. 1 second. Um, OPENCV. 1 second, please. Before. Sadly, I closed it. I don't have it in the reference, so I'll have to find it. Wait. Face detection. Yes, this one. Okay. Okay, how can I? Oh, maybe. Okay. So I can show you this one of the references that you can follow. There are a lot of websites. I can share some of them after, but there are a lot that have many different. Many have. Can we make an idea that this video is fake? I don't understand your question totally. Can we make an idea that this video is fake? Like, do you mean if you like create a fake video and you? I'm not totally sure. Maybe if you can reword your question. Anyway, let's go back to here. So in this tutorial, that is step by step, you can see how to do a real-time face detection with OpenCV. So it is very simple, and it actually used the same classifier as before, which is the cascade classifier. So this scheme should be familiar now, right now. The only add thing that we will have to open our camera. So it's very simple if we use Jupyter, which I don't have in the current laptop I'm working on. It's on my PC. However, if we this is just is opening your camera, which is 0, and if you have multiple camera, it will be 1, 2, and so on. If we try to use this code, it will not show any error in the Google Colab, but it will basically just not work because it doesn't have the function. Let's see code. Now it will run, but it will not open any new tabs with the camera. However, if you do it with the Jupyter Notebook on your on laptop, it will work. Okay. So after that, we will just do the same thing by detect the bounding box. We will, as we said before, we'll convert it to gray image using the color blue green to gray, and then we will use the function in the classifier. After that, we will create a loop. Why we need a loop here? Because it's a video, it's not one picture. So the loop need to be continuous for the picture for the video until it stops. And here is a showcase of that. So that is but it will be covered in the next sessions more in depth. This is just a beginner to OpenCV because if we really think about it, like any AI models or most of them that like deal with pictures or videos, the first step is to deal with the video or image itself. So we can use that by OpenCV. No, okay. Can we classify? Yes, if it is has an image, this actually depends on the model itself, how strong it is, and does it have those. I don't think like any model have been through or like been tested on the AI generated, so maybe it will have some issues, but it's a possibility. But if you want it to work optimal, you will have to train your model by yourself on the AI generative real videos or pictures, and then after that test it. Can be used identify multiple phases in one image? Yeah, we can see in this it has 2 images, and we managed to identify both of them. Okay. I think time running slow, so I don't want to end without a Q&A question and showing the references that will help you grow your knowledge in OpenCV. So please ask or let me know if you need anything. Because as said before, how to perform video compression in Colab. Yes, someone talk. Can you please repeat? What do you mean by like? Do you mean like making the video shorter or longer? Yeah, I think it's possible because Python. If first of all, am I understanding your question right? Do you mean like making the video shorter or longer, or do you mean as in size? You want to compression the video to be like longer size, as in kilobytes? What exactly? Please rewrite your question so I can understand it clearly. In the meantime, I would like to show some references that will.
You can use your microphone and ask the.
Yeah, you can feel free to ask anything. Here are some references. Only three, but actually the sky is the limit. If you search on Google, YouTube, you will find many. So the knowledge is always there. It's just upon you to go learn, see how it's done, and test try by yourself. Coding is actually a lot of trial and error rather than memorizing or knowing the syntax, because knowing the syntax, because for example, like let's say this fast cascade function, I can just search it and see what is the syntax, and then I can for example input my own syntax or input my own variables. So it's a lot of trial and error, so you should be trying a lot. uh, Here some of the references that I advise you guys to look at. Firstly, we have this website. This website has a tutorial, a guiding tutorial for OpenCV from the beginning, where we can have from getting started, image processing, features, drawing functions, until for example AI models and so on, application of projects. For example, face detection using Python with the webcam, as we said, and so on. So I would recommend going through this website. Another thing, if you are GitHub, if you know how to, if you have been using GitHub and so on, here is a full notebook that you can a full notebook that you can go through in GitHub. And there are like many other even more comprehensive notebooks. But this is like I remember when I was doing AI for the first time a couple of years back. It was the notebook that I learned from. So it's basically OpenCV from the very beginning, where it teaches you fundamentals, image status, for example, detecting faces and so on. And it had the code. You can download the notebook in itself and like run the code, and you can try and error. Mm, the case most of the time, not every code will work for you, even though it worked for them. So you'll have to get your way around it. Finally, another final reference I want to showcase is this YouTube channel, and there are many other YouTube channels, but this one I forgot an H. Okay, so this YouTube channel has a 4-hour course, and they have also like 5 minutes. Sorry, they have also like if you go this course, there is a 5 minute of each topic, so you don't have to watch it in one. You can go to the playlist and you will find let's search about OpenCV. So here you have the 4 hours, but where's the playlist? Yeah, I will link the playlist after, but the playlist basically is the 4 hours divided into small topics, 5 minutes each, and you can see the timeline here. So here you can like choose, for example, what part are you interested in, and I would recommend going through it from the beginning. So this is like most the references that I would recommend. But as said before, the the internet now has like many resources, and even AI can help us with our own code, correcting mistakes. But try always to use it to understand and get knowledge, not to do your work. So yeah, of course we have to use AI, but I will always try to write my own code, and then if it has errors, I will use the help of, for example, Gemini in Google Colab to help me fix this. But it's not advice to make it write the code from the beginning. I think that's we have 5 minutes because the next session should be starting soon. So once again, please let me know if you have any question. Please send the links. Yeah, sure, I will. Okay. You may, I will share the link for the slide first and foremost, and then I'll share these three links. Yeah, should be okay now. Okay. Can you double check if they are working, someone? If there's anything, I'd like to end my speech here and maybe take 3 minutes break before the next session. Thank you so much for listening, and feel free after the session's end to ask if you have any questions or if you tried your own code and like you need help with it. Inshallah, I will be available. That's all from me. Thank you so much. Jazakumullah khairan.
Thank you very much, sir,
No
for
worries,
this
brother.
wonderful session.
Brother,
I
your mic
hope
is
the participants have
yes,
really taken extensive knowledge about the OpenCV. I think
yes,
their fundamentals doubts have been clarified, and they can build their foundation to learn about OpenCV from
yes,
this session.
yes. And it will be like when you
And
go to the next sessions where we talk about PyTorch, YOLO V5, and more comprehensive AI, you will see the real usages of OpenCV.
yes, so the speaker has posted all the
Links.
required
Yeah,
links in the chat
I
also.
will post the drive link because it's been a lot of messages. This drive link with the notebook that I used, you can look at through it. Try your code. Try the code yourself.
We will also share the same resources in the WhatsApp group for all the participants. Okay, thank you very much, sir, for this
Thank you so much.
wonderful session.
Thank you so much, and good luck for your certifications.
Shortly, we'll be starting with our next resource person, our next session.